Picture a delicate golden equilibrium that has perfectly balanced a brilliant sphere for over 5 billion years, suddenly beginning to falter and crack. The crushing weight of gravity, once effortlessly held at bay by the fiery outward push of continuous nuclear fusion, finally seizes absolute control of a starving core. This is the precise, terrifying moment a star stops being a reliable, warming sun and embarks on a majestic, system-spanning metamorphosis. Imagine an unstoppable, silent wave of unexpected heat rolling outward into the freezing, forgotten reaches of a distant planetary neighbourhood. Places that were once frigid, silent cemeteries of solid methane and ancient ice are suddenly bathed in an intense, pervasive, ruby-coloured warmth. Dormant, frozen moons begin to groan and melt under the new light, creating vast, temporary oceans of liquid water in the absolute twilight of their world. This cosmic structure is fundamentally caught in an impossible physical contradiction, a state where the very laws of nature seem to fold upon themselves. The dying Titan is simultaneously collapsing inward at its desperate white-hot heart, while its tenuous outer atmosphere expands rapidly to devour the surrounding vacuum. It is a beautiful, terrifying paradox of simultaneous destruction and creation, a delicate gravitational high-wire act balanced on the very edge of the abyss. Surprisingly, the sheer violence of this celestial transformation is the exact mechanism that breathes the potential for organic life out into the dark. Trillions of tons of heavy alchemical elements are actively forged in the shrinking centre and gently exhaled into the interstellar wind. The carbon in your own physical form, the iron in your resting blood, and the oxygen filling your slow breaths were all manufactured in these exact glowing furnaces. If we were to look closer at your own quiet room, the chaotic, roaring energy of these stellar titans fades into a profound, heavy stillness. The walls around you are solid, the blankets are warm, and you are completely, undeniably safe in this present moment. These wonders are yours to inherit as you sleep, a magnificent cosmic lullaby whispered across millions of light years directly to your resting, peaceful mind. Your steady heartbeat perfectly mirrors the slow, agonizing and beautiful rhythm of the heavens above as you sink deeper into the mattress. Let go of the day's lingering weight and allow your imagination to drift effortlessly into the absolute pristine dark. Deep within the cosmos, average stars eventually exhaust their hydrogen and begin a dramatic transformation. Deep within the cosmos, average stars eventually exhaust their hydrogen and begin a dramatic transformation. For billions of years, a delicate equilibrium holds a star together, balancing the crushing weight of gravity against the fiery outward push of nuclear fusion. This cosmic dance, however, is destined to falter when the pristine hydrogen fuel at the core finally runs dry. Without the steady roar of hydrogen burning, the core begins to contract, yielding to the relentless inward pull of its own mass. As the center collapses, it releases an immense surge of gravitational energy that cascades outward through the star's layers. This sudden rush of heat reignites dormant hydrogen in a shell surrounding the dead core, sparking a new, furious phase of fusion. The outer envelope of the star responds to this intense new energy source by billowing outward into the freezing vacuum of space. What was once a stable, yellow sphere begins to bloat and distort, embarking on a majestic and terrifying metamorphosis. The gentle swell of a dying sun has begun, painting the surrounding dark with the first hints of a soft, pervasive crimson glow. Picture a celestial sphere expanding to hundreds of times its original size. The scale of this cosmic swelling is truly difficult for the human mind to fully grasp. If you were to place such a stellar giant in the center of our own planetary neighborhood, its sheer volume would devour the orbits of the innermost worlds. This phenomenal growth is not a sudden explosion, but rather a relentless, unstoppable stretching of hot plasma across millions of miles of empty space. the star's outer layers become utterly detached from the intense gravity of the dense core, drifting outward like a massive glowing balloon. As the gas travels further from the central furnace, it begins to thin out, creating an immense ghostly silhouette against the backdrop of the Milky Way. To an observer floating in the distant void, the star would appear as a monstrous swelling orb dominating the heavens. Its edges would seem diffuse and ethereal, lacking the sharp, defined boundary of a younger sun. This breathtaking expansion turns an ordinary point of light into a terrifyingly beautiful, system-spanning behemoth. The surface of this swollen giant cools significantly, shifting its light to a warm, soothing red. As the stellar atmosphere expands across such vast distances, the heat generated deep within the core is spread increasingly thin. The incandescent white or yellow brilliance of the star's youth gradually fades, giving way to a darker, more melancholic hue. Temperatures at the outermost edge of the star plummet to a mere fraction of what they once were, cooling to roughly 3,000 degrees. At this lower temperature, the physics of light emission dictate a dramatic transformation in the star's visible spectrum. The high-energy blue and yellow wavelengths diminish, leaving behind a profound, pervasive crimson glow that bathes the surrounding cosmos. This colour shift transforms the nature of the starlight from a harsh, blinding glare to a deep, mesmerising radiance. It is a sunset colour projected onto a galactic scale, a visual testament to the cooling fires of a dying world. The star now broods in the dark, radiating a majestic, ruby-toned warmth that feels paradoxically calm despite the raging nuclear furnace hidden deep within its heart. Curiously, despite the cooler exterior, the total luminosity increases dramatically. It seems counterintuitive that a star whose surface is losing heat could simultaneously become one of the brightest objects in its local galactic neighbourhood. The secret to this paradox lies not in the intensity of the light emitted from any single patch of the star, but in the sheer, unimaginable magnitude of its new surface area. This immense total energy output guarantees that red giants act as brilliant beacons visible across the vast, dusty expanses of the galaxy. They dominate the visual landscape of ancient star clusters, standing out like glowing embers among fading ashes. The dying sun achieves its greatest glory just as its foundational fuel is finally exhausted. If we were to look closer, the sheer optical power of these dying titans becomes overwhelmingly apparent. A single red giant can outshine our sun by a factor of thousands. To stand on a hypothetical planet orbiting at a safe distance from such a star would mean existing under a sky ablaze with relentless, overpowering red light. Our own sun, which provides all the necessary energy to sustain the teeming biosphere of Earth, is but a dim spark compared to the raging bonfire of a red giant. The energy radiating from the giant's vast surface pours into the vacuum with an intensity that can push against the very fabric of interstellar dust clouds. This flood of illumination is driven by the furious, desperate hydrogen burning occurring in the shell just outside the dead core. Astronomers rely on this incredible brightness to trace the structure and history of our universe, using these giants as glowing mile markers in the dark. Their luminosity allows them to be seen across unimaginable cosmic distances, piercing through the obscuring veils of galactic nebulas. They are the undisputed luminous kings of the older stellar populations. In fact, the density of a red giant's outer envelope is less than that of the highest quality vacuums created in laboratories here on Earth. If you could somehow scoop up a handful of this atmospheric material, it would weigh virtually nothing, feeling like a phantom breath of heat rather than a tangible substance. Yet, because this near vacuum is incredibly hot and stretches for millions of miles, it collectively forms an opaque glowing crimson shroud. This gossamer texture means that the boundary between the star and the empty space surrounding it is incredibly blurry and undefined. The star does not so much end as it gradually fades away into the dark interstellar medium. It is a ghost of a star, a colossal glowing illusion built from almost nothing at all. To truly comprehend the horrifying majesty of this scale, one must bring the concept closer to home. If placed in our solar system, a typical red giant would easily swallow Mercury and Venus. The familiar rocky worlds of our inner system would be instantly vaporized, consumed by the swelling tide of thin, incandescent plasma. The space where these planets once danced in their ancient, stable orbits would become part of the deep, churning interior of the star itself. Mercury, a sun-baked cinder of iron and rock, would be the first to vanish, melting away into the stellar atmosphere without a trace. Venus, with its thick, suffocating clouds of acid, would follow shortly after, its entire mass absorbed into the convective rivers of the giant. The destruction of these ancient worlds would barely register as a tremor in the overall structure of the dying star. They would simply cease to exist, their elemental components mixing into the vast, red-glowing vacuum. This terrifying scenario paints a vivid picture of the sheer, uncompromising dominance a red giant exerts over its immediate cosmic environment. Surprisingly, the universe offers no guarantees for the safety of our own blue marble in this apocalyptic future. Earth itself might barely skim the outer atmosphere of such a massive stellar entity. As the Sun begins its inevitable expansion billions of years from now, our planet's orbit will become a precarious, fiery tightrope walk. Our world would be suspended directly on the blurred, glowing edge of the stellar vacuum, bathed in a heat so intense that the oceans would boil away into space. The crust of the Earth would melt into a global ocean of glowing magma, completely sterilizing the planet of all its ancient history and biological legacy. Even if the Earth's orbit pushes outward slightly due to the Sun's decreasing mass, it will remain trapped in a lethally close embrace. The friction generated by moving through the star's tenuous outer atmosphere could eventually drag our planet spiraling inward to its ultimate doom. Whether swallowed whole or left as a scorched, barren rock skimming the surface, the Earth's fate is inextricably tied to the swelling crimson tide. It is a humbling reminder of our fragile temporary existence within a dynamic and violent cosmos. Unlike the sudden, catastrophic detonations of massive supernovas, this profound celestial death is a study in agonizingly slow motion. This expansion happens slowly over millions of years, a silent stretching in the dark. To a hypothetical immortal observer watching from a nearby star system, the transformation would be imperceptible on the scale of a human lifetime. Generation after generation could look up at the sky and see the exact same pinpoint of light, completely unaware of the massive structural changes occurring within the stellar interior. The giant swells outward by only a few fractions of an inch every second, a creeping tide of plasma that gradually conquers the surrounding void. It is a quiet, majestic doom, devoid of sound or immediate fury, driven by the inescapable laws of thermodynamics and gravity. This glacial pace underscores the vast, deep timescales upon which the universe operates, dwarfing our mortal understanding of duration. Millions of years of silent, continuous growth are required to build these ruby-coloured monuments in the galactic sky. The gentle swell of a dying sun is a masterpiece painted with the slowest, most deliberate brushstrokes imaginable. We do not have to rely solely on mathematical models to witness this breathtaking cosmic phenomenon. Looking at the night sky, Betelgeuse offers a perfect naked-eye example of this brilliant crimson phase. Situated at the prominent shoulder of the constellation Orion, this vibrant star has captivated human stargazers for countless millennia. Even without the aid of a telescope, the distinct fiery orange-red hue of Betelgeuse is unmistakably different from the icy blue-white of its neighbouring stars. It pulses and flickers with a slow, irregular rhythm, a visible heartbeat betraying the violent, chaotic convection currents churning beneath its bloated surface. This massive supergiant is so incredibly vast that if it replaced our Sun, its surface would extend out past the orbit of Jupiter. By simply looking up on a clear, crisp winter night, anyone can directly observe the final, magnificent throes of stellar evolution. Betelgeuse stands as a glowing ruby-toned sentinel in the dark, reminding us of the beautiful, terrifying and endlessly fascinating life cycles of the stars. It is the perfect living embodiment of the gentle swell of a dying sun. Beneath this gentle swell of the dying sun, hidden deeply beneath the puffy, ethereal exterior, a violently different reality unfolds. While the outer layers drift lazily into the freezing void, the very heart of the star experiences a terrifying collapse. A dead core, exhausted of its primary fuel, begins to shrink relentlessly under the crushing weight of the entire stellar mass pressing down from above. Paradoxically, this rapid shrinking process generates a horrifying, unimaginably intense silent heat. The kinetic energy of falling matter translates directly into a skyrocketing temperature, turning the dead center into an invisible, glowing ember of astronomical proportions. It is a star within a star, contracting and broiling in absolute darkness, while the outer shell masquerades as a cool, tranquil giant. If we could peer into this abyssal heart, we would witness gravity mercilessly crushing the inert helium ash left behind by eons of earlier fusion. This byproduct, once completely useless to the star, is now subjected to forces that defy common comprehension. The relentless squeezing forces the helium nuclei closer and closer together, overcoming their natural, powerful magnetic repulsion. Deeper and deeper, the core plunges into extreme states of matter, driving the ambient temperature to an unfathomable peak. The heat inside this shrinking sphere eventually reaches a blistering threshold of roughly 100 million degrees, a temperature far hotter than the star ever experienced in its youth. At these apocalyptic extremes, the very fabric of the atoms begins to vibrate with a frenetic, almost desperate energy. Such unimaginable heat radiates outward in profound silence, a lethal, invisible fire locked deep within the stellar vault. The immense thermal pressure battles against the squeezing grip of gravity, creating a localized environment of pure, unadulterated stress. This is the ultimate cosmic crucible, preparing the long-dead ash for a miraculous and violent resurrection. As your body rests completely supported in this moment, allow your mind to drift into that tense, overheated stellar core just before the breaking point. Without warning, the critical threshold of temperature and pressure is breached, and the dormant helium ash violently ignites. This event, known to astrophysicists as a helium flash, is an explosive runaway reaction of staggering magnitude. In a matter of mere minutes, this hidden detonation releases as much energy as an entire galaxy of ordinary stars. Yet, remarkably, absolutely none of this apocalyptic flash is visible from the outside of the red giant. The sheer weight and thickness of the surrounding stellar layers absorb the entire shockwave, muffling the greatest explosion of the star's lifetime. The intense burst is trapped completely within the deep interior, a silent scream of nuclear rebirth swallowed by the massive glowing envelope. The core is instantly transformed from a dead, contracting weight into a raging, hyperactive engine of immense power. This hidden detonation fundamentally rewrites the destiny of the dying celestial titan. The sudden infusion of explosive energy forcefully halts the core's desperate collapse, pushing back against the crushing weight of gravity. This fierce internal ignition stabilizes the star for a brief, glorious epoch, forging a brand new, vastly hotter furnace in the stellar depths. The chaotic, runaway burning quickly settles into a steady, controlled roar, establishing a temporary peace within the turbulent giant. Empowered by this rejuvenated heart, the star finds a precarious new equilibrium, pausing its dramatic outward expansion. The core, now actively burning helium instead of hydrogen, sustains itself at a much higher operating temperature than ever before. It becomes a localized epicenter of blinding white-hot intensity, a second lease on life wrested from the jaws of gravitational doom. For countless eras, this secondary furnace will hum with incredible efficiency. It is a completely different kind of stellar engine, Running on the exhaust of the star's younger days, the dying giant has successfully reinvented itself from the inside out, discovering a fresh source of vitality in the ashes of its past. Within this newly minted furnace, the blistering heat and pressure force the reluctant helium atoms to do the impossible. They are violently smashed together, their nuclei merging in a complex atomic dance to forge heavier, more complex elements. The primary products of this desperate fusion are the elemental building blocks of carbon and oxygen. This alchemy requires precise, almost miraculous conditions, as three separate helium nuclei must collide almost simultaneously to create a single carbon atom. It is a precarious cosmic lottery playing out on an unimaginable scale, trillions of times every second. As the fusion continues, oxygen is also synthesized, layering the core with the vital ingredients required for complex chemistry. Notice the profound irony that the star must reach the brink of death to finally manufacture the elements essential for organic existence. The dead ash of its youth has been transmuted into the foundation of future worlds. This deep, internal forge silently cooks the universe into a richer, more diverse tapestry of matter. Just as your breathing settles into a steady, rhythmic pace, the star also maintains a dual rhythm of energy production. Surrounding the newly ignited, incredibly hot inner core is a secondary active shell of leftover hydrogen that continues to fuse. This creates a nested, glowing structure of nuclear reactions, with distinct layers burning entirely different fuels simultaneously. The inner helium furnace blazes with intense heavy element creation, while the outer shell continues the simpler, older process of hydrogen burning. The heat radiating from the deep center actually stimulates and accelerates the fusion in this surrounding layer. This concentric arrangement of burning shells makes the internal structure of the red giant incredibly complex and heavily stratified. It is a testament to the sheer scale of the star that entirely different physical regimes can exist, separated by thousands of miles of roaring plasma. The simultaneous burning ensures a massive, continuous outpouring of energy that keeps the outer envelope bloated. The star is furiously burning its candle at both ends, consuming its remaining resources at an alarming, accelerated rate. This complex architecture results in a fascinating duality: a dense, incredibly hot core working in tandem with a diffuse, rapidly expanding outer atmosphere. The relationship between these two vastly different regions creates a highly delicate, system-wide gravitational balancing act. Every shift in temperature at the center ripples outward, dictating the vast physical dimensions of the cooler exterior. If the core flares up and burns hotter, the increased radiation pushes the outer layers even further away, cooling the surface more. Conversely, if the core's output dips slightly, gravity seizes the opportunity to pull the diffuse envelope back inward. The entire star becomes an interconnected machine, governed by the fragile tension between inward crushing weight and outward thermal expansion. It is a spectacular high-wire act performed across millions of miles of empty space. The red giant is not a static object, but a living, adjusting system constantly seeking a stable posture. This dynamic equilibrium is beautiful, fragile, and ultimately doomed to fail. Consider the sheer, unadulterated physical pressure required to physically crush distinct atoms together until they violently merge. Down in the deepest stellar depths, the weight of the overlying gas is roughly equivalent to balancing an entire mountain range on the head of a pin. The matter is squeezed so relentlessly that the protective electron clouds surrounding the atomic nuclei are stripped away entirely. In this ultra-dense state, the naked nuclei are packed shoulder to shoulder, vibrating with the unimaginable kinetic energy of the surrounding heat. They violently repel one another due to their matching positive charges, fighting against the crushing environment. Only the overwhelming, inescapable vice grip of gravity forces them close enough for the strong nuclear force to finally snap them together. The environment is so extreme that it defies any terrestrial comparison, representing a state of physical stress found almost nowhere else in the cosmos. It is a domain of pure, crushing force and blinding, lethal radiation. This hostile, hidden underworld is the exact location where the universe's most important alchemy occurs. Allow your shoulders to drop and your muscles to relax, sinking into a state of deep, undisturbed calm. While the core is a scene of instant, violent fusion, the energy it generates embarks on a painfully slow, agonizing journey. The photons created in the center take countless millennia to migrate outward through the incredibly dense, opaque layers of the stellar interior. A single particle of light does not travel in a straight line, but is constantly absorbed and re-emitted by the densely packed plasma. It bounces frantically in random directions, executing a drunken, meandering walk through the internal darkness. A photon generated during the dawn of prehistoric eras might just now be reaching the outer edge of the red giant. This immense delay means that the red light shining from the surface today is actually ancient history, a delayed echo of past nuclear triumphs. The exterior of the star is perpetually lagging behind the reality of its central engine. By the time the energy finally escapes, the core that produced it may have already drastically changed its state. When that weary particle of light finally breaks free of the star's tenuous grasp, it accelerates into the cold, pristine vacuum of space. Every single photon released carries the encoded story of this profound, violent internal metamorphosis. Its specific wavelength, its slight dimming, its shifting spectral lines, all are secret messages detailing the exact conditions of the hidden furnace. By capturing these ancient, exhausted rays of light, observers can reconstruct the harrowing journey the energy endured. The light speaks of crushed helium ash, of hidden detonations, and of the delicate, precarious balance holding the giant together. It is a continuous, silent broadcast transmitting the internal autobiography of a dying sun across the dark expanses. As these rubies of light wash over distant worlds and dormant celestial bodies, they deliver the final magnificent testament of the stellar forge. The secret alchemy of carbon and oxygen is written into the very glow that illuminates the void. The furnace reforged has permanently left its signature on the eternal incoming tide of starlight. Riding this eternal incoming tide of starlight back to its source reveals a surface utterly unlike the tranquil glow suggests. Rather than a smooth, continuous sphere, the very face of the dying titan is fractured and boiling. The familiar granular texture seen on a typical yellow dwarf is magnified here to an apocalyptic scale. Our own local sun features tiny, churning pockets of gas that constantly bubble up and dissolve in a matter of minutes. In stark contrast, a red giant's surface features convection cells so monstrously large they defy ordinary geometry. A single one of these bubbling structures could easily swallow entire planetary systems whole without a trace. Deep within this bloated atmosphere, the physics of fluid dynamics are stretched to their absolute macroscopic limits. These gargantuan geometric patches shift and warp with terrifying momentum, dominating vast regions of the stellar hemisphere. It is a mosaic of colossal, moving puzzle pieces floating on an ocean of liquid fire. Driven by the fierce heat of the reforged central furnace, matter deep within the envelope begins a massive upward migration. Enormous plumes of superheated plasma detach from the lower depths and force their way outward against the crushing weight of the star. This buoyant material carries the vital thermal energy necessary to keep the immense outer boundary inflated. Surprisingly, this upward journey is not a swift or explosive ascent through the stellar layers. Instead, the heated gas from the interior rises sluggishly, fighting its way through immense physical resistance over countless years. The sheer distance it must traverse turns a violent upwelling into a slow, agonizing crawl toward the vacuum. As these monumental columns of plasma finally breach the surface, they release their pent-up thermal energy into the void. This slow delivery system continuously resupplies the fading warmth of the outermost tenuous layers. Without this sluggish, relentless conveyor belt of heat, the bloated atmosphere would swiftly collapse inward. Once the plasma has surrendered its fierce internal heat to the freezing darkness of space, its physical properties alter drastically. Deprived of thermal buoyancy, the material becomes noticeably denser and heavier than the actively rising currents beside it. The radiant, blinding hue fades into a comparatively muted, ominous shade of deep crimson. Upon reaching the absolute edge of the star, this exhausted gas cools, darkens, and inevitably surrenders to gravity. It begins a long, majestic descent, sliding down the edges of the rising convection cells like a colossal crimson waterfall. Trillions of tons of cooled plasma plunge back down into the terrifying pressurized depths of the stellar interior. This continuous cyclical motion establishes a permanent churning engine of planetary proportions across the entire surface. The descending channels of cooler matter carve deep, darker ravines between the brilliant bloated summits of the rising plumes. It is a perpetual, majestic overturning of an entire world's worth of atmosphere. As you feel the steady, reassuring rise and fall of your chest, consider the chaotic rhythm of this stellar breathing. The sheer scale and violence of these overturning currents fundamentally distort the overall geometry of the dying sun. It can no longer maintain the perfect, smooth, spherical shape dictated by simple gravitational equilibrium. These massive, restless convective currents cause the star's outer boundary to become profoundly irregular and lumpy. The rising plumes push the surface outward into mountainous bulges of glowing plasma, while the sinking cooler gas creates immense, sweeping valleys. The silhouette of the giant against the cosmic dark is not a perfect circle, but a shifting amoebic blob. If one could stand far enough away to view the entire entity, it would appear to writhe and undulate slowly over time. Vast regions swell outwards, while others simultaneously collapse inward, creating a terrifyingly asymmetric profile. The star is effectively boiling out of its own skin, its boundary constantly redefined by the internal rivers of fire. To grasp the visual reality of this phenomenon, picture a simmering pot of thick soup left atop a slow fire. The viscous liquid heaves and bulges, occasionally breaking the surface in sluggish, heavy eruptions that spread outward in wide ripples. Now, magnify that mundane kitchen scene until those very bubbles measure millions of miles across. Each individual, swollen pocket of plasma contains enough mass and volume to dwarf the largest gas giants in existence. They dome upwards like blisters of light, their surfaces marred by the darker, cooler material sliding down their flanks. It is a mesmerizing, horrifying display of fluid mechanics operating on the grandest stage imaginable. The friction between these shifting, continental-sized bubbles generates immense turbulence in the upper atmosphere. Colossal waves of sound and kinetic energy crash along the boundaries where ascending and descending currents collide. This simmering surface is a chaotic wasteland of thermal energy, desperately trying to escape its gravitational prison. Interwoven through this boiling chaos is an invisible architecture of immense unseen power. The dying star possesses an intricate network of magnetic field lines, originally generated deep within its spinning core. As the gargantuan convection cells heave and overturn, they drag these invisible lines of force along with them. The magnetic fields are ruthlessly stretched, tangled, and twisted by these colossal, churning rivers of plasma. What was once an orderly, symmetrical magnetic structure becomes a hopelessly knotted, chaotic web of tension. The kinetic energy of the moving gas overpowers the magnetic tension, forcing the fields to conform to the boiling topography. Eventually, these knotted lines of force store an incredible amount of latent energy, snapping like over-tightened cosmic rubber bands. When they break and reconnect, they release violent bursts of radiation and heat into the surrounding void. This magnetic torment adds an invisible layer of violence to an already turbulent and hostile environment. Let the tension slip from your jaw, finding comfort in the quiet stillness of your own environment. far removed from this magnetic chaos. In areas where these twisted magnetic fields become overwhelmingly concentrated, they act as an invisible barrier against the rising heat. The upward flow of hot, buoyant plasma is forcefully choked off, starved by the intense magnetic pressure. Cut off from the vital heat of the interior, these localized regions of the surface cool rapidly compared to their surroundings. Occasionally, massive star spots form as a direct result, creating dark, brooding patches across the vibrant red canvas. These blemishes are truly gargantuan, spanning areas vast enough to engulf dozens of average-sized worlds. While they appear black against the blinding brilliance of the star, they are still searingly hot by terrestrial standards. Their darkness is purely an optical illusion, born of contrast against the hotter, uninhibited convection cells roaring nearby. They look like massive bruised indentations on the skin of the churning Titan. The expansion of the dying sun has forced its angular momentum to stretch, causing its once rapid spin to slow to an agonizing crawl. A single day on this swollen sphere can take countless months or even years to complete. This sluggish turning dictates the lifespan and behavior of the dark magnetic blemishes scarring its face. On a smaller, faster spinning celestial body, such spots are quickly sheared apart by the rapid differential rotation. However, the extraordinarily slow rotation of the red giant means these star spots can last for years before finally dissolving. They become semi-permanent fixtures on the star's geography, glaring out into the dark like massive, unblinking eyes. Over their incredibly long lifetimes, these dark patches slowly migrate and warp, carried along by the underlying rivers of fire. They act as anchors of magnetic turmoil, occasionally launching massive flares of trapped energy out into the stellar wind. Watching one of these spots form and fade is to witness a geologic-scale event in the atmosphere of a star. The relentless churning, bubbling, and magnetic snapping generates more than just visual chaos. It produces a symphony of low-frequency pressure waves. Every collision between convection cells, every sinking plume, acts as a massive hammer striking the atmospheric anvil. This creates a cacophony of deep, booming infrasound completely inaudible to human ears, but devastating in its physical power. These immense sound waves propagate outward and inward through the boiling layers of the envelope. The outer boundary of the star reflects the waves back down, while the dense core forces them to bend upward again. This continuous bouncing turns the entire swollen entity into a gargantuan, resonating acoustic cavity, much like a cosmic bell. The star literally rings with millions of different overlapping frequencies, creating a complex harmonic signature. The entire structure pulses and vibrates in response to this trapped sonic energy, a silent thrumming echoing through the vacuum. It is a celestial instrument played by the violent turbulence of its own boiling surface. Allow your awareness to trace the gentle rhythmic beating of your own pulse, a tiny biological echo of these massive rhythmic vibrations. While the actual sound cannot travel through the vacuum of space, the physical ringing causes the star's light to fluctuate in incredibly subtle ways. The surface heaves in and out with the trapped acoustic waves, altering the colour and intensity of the escaping photons. By carefully monitoring these minute flickers, earthly observers can perform a miraculous feat of stellar seismology. Astronomers can essentially listen to these subtle vibrations, mathematically decoding the trapped frequencies to map the otherwise hidden interior. The specific pitch and rhythm of the ringing reveal the exact density, temperature, and composition of layers buried millions of miles deep. Through this acoustic science, the opaque, boiling rivers of fire become transparent to the probing minds of researchers. The giant inadvertently broadcasts its deepest structural secrets through the trembling of its ruby-toned light. It is a breathtaking realization that the chaotic rumbling of a dying sun provides the exact key needed to understand its hidden heart. The realization that the chaotic rumbling of a dying sun provides the exact key needed to understand its hidden heart brings us to a fragile boundary where the giant's physical influence begins to slip. At these extreme, bloated distances from the core, the gravitational hold on a red giant's outer layers is remarkably weak. The force that once held the star in a tight spherical grip is now stretched across hundreds of millions of miles, leaving the surface material precariously balanced on the edge of the abyss. Deep within the core, gravity remains a crushing tyrant, but out here, the inverse square law of physics has turned that iron grip into a soft, tentative touch. The outermost plasma is so far removed from the centre of mass that it barely feels the pull of its parent star at all. This lack of gravitational authority means that even the slightest outward nudge can send vast quantities of stellar matter drifting away into the freezing dark forever. It is a state of profound physical instability, where the star's very boundary becomes a blurred and porous interface. Without a strong central anchor, the atmosphere begins to unravel, fraying at the edges like a piece of ancient weathered silk. This weakening of the internal bond is the essential prerequisite for the star's final, most generous act of cosmic distribution. Because of this fragile grip, the star begins to exhale its mass into the surrounding void in a quiet, continuous stream of plasma and gas. This is not the violent, explosive shedding seen in more massive celestial bodies, but rather a rhythmic and inevitable release of the star's own substance. It is as if the Titan, having grown too large for its own skin, simply allows its outer identity to spill over into the dark silence of the interstellar medium. This process represents a slow and steady dissolution of the self, a literal unmaking of the stellar body that has existed for billions of years. Trillions of tons of hydrogen and helium, once the core components of a vibrant sun, now drift away as a ghost-like mist. The star is no longer a closed system, but a leaking vessel of light and matter that pours its history out into the vacuum. Notice how this quiet exhalation contrasts with the frantic nuclear fires burning deep within the interior. While the heart of the giant is a scene of intense struggle and fusion, the breath of the giant is a peaceful, outward-bound journey. This steady loss of mass begins to define the star's final epoch, marking the transition from a stable sun to a dispersing cloud of cosmic memory. These stellar winds are much slower and denser than the fierce solar wind produced by a younger, more energetic star like our own sun. While the solar wind is a high-speed torrent of charged particles screaming away at millions of miles per hour, the giant's breath is a heavy, sluggish drift. It moves with a ponderous and inevitable momentum, a thick breeze that carries an immense amount of physical matter into the surrounding void. The density of this wind is so high that it creates a tangible, opaque environment around the star, a shell of matter that can obscure the giant's own light. It is a slow-moving river of plasma, lacking the kinetic fury of a younger star, but possessing a far greater collective mass. This sluggishness allows the expelled material to interact and cool in ways that are impossible in the fast-moving winds of smaller suns. Surprisingly, the very slowness of this wind is what permits the star to begin its most complex chemical work. Because the material lingers near the star for longer periods, it has the time necessary to transition from a state of ionized plasma into something far more intricate. The ponderous pace of the giant's breath is the key to the molecular wonders that are about to form in the cooling darkness. As you lie here, feeling the weight of your body pressing into the surface beneath you, contemplate the weightlessness of these microscopic sails. Surprisingly, as this hot gas moves further into the cold dark, it undergoes a miraculous chemical transition from a gaseous state into solid matter. Dust grains condense in the cooling outer atmosphere, forming microscopic particles of silicate and carbon that act like tiny sails catching the star's light. These solid specks of matter are the first tangible pieces of a future world, born in the frigid outskirts of a dying sun. They are incredibly small, yet they possess a physical presence that the surrounding gas lacks, providing a surface for the star's immense radiation to push against. The photons streaming from the core strike these tiny sails with a continuous invisible force, turning the star's own light into a literal engine of propulsion. This interaction is the ultimate synergy between the star's internal fire and its external shedding. The light produced by the death of atoms in the core is the very thing that drives the birth of dust in the atmosphere. Each grain of stardust is a vessel for momentum, catching the ruby-toned radiance and carrying the star's essence deeper into the galactic night. This mechanism creates a self-reinforcing cycle of mass loss that accelerates as the star grows more luminous. The brighter the giant becomes, the more radiation pressure it exerts, and the more dust it can drive into the interstellar medium. It is a beautiful and efficient system of removal, stripping the giant of its outer identity layer by layer without the need for a single explosion. The light and the matter are locked in a final embrace, moving together away from the source of their creation. This continuous outward-bound push clears the space around the star, creating a vast corridor of expanding material. The radiation pressure acts as a cosmic broom, sweeping the star's history out into the dark to make room for what is yet to come. Imagine a celestial dandelion shedding its seeds into the galactic wind, a grand dispersal of life-giving material across the void. The red giant in its final stages becomes a beacon of redistribution, casting off the elements it spent eons forging in its internal furnace. Each grain of dust and every molecule of gas is a potential seed for a future world, drifting through the darkness toward an unknown destiny. This dispersal is the mechanism by which the universe heals its own barren stretches, enriching the empty space between stars with the raw ingredients of complexity. The red giant is not simply dying, it is planting a garden in the deep dark, ensuring that its legacy will bloom in the form of new suns and new planets. It is a selfless act of cosmic stewardship, a scattering of self that allows the galaxy to continue its long, slow evolution. Notice the grace in this shedding, a quiet and orderly release that stands in defiance of the entropic dark. The star becomes a source of abundance, its breath, a gift to the future that will be felt billions of years from now. The celestial dandelion eventually disappears, but its seeds remain, floating in the cosmic currents until they find a new home. Notice the stillness in your own hands, a quiet contrast to the star that is slowly letting go of its entire physical legacy. Deep within this process of shedding, the star undergoes a radical physical downsizing that fundamentally alters its future path. Over time, a red giant can lose more than half of its original mass through this gentle, unrelenting exhalation of its own substance. This loss is so significant that it changes the very gravitational math of the star's existence. As it becomes lighter, its hold on its remaining layers weakens even further, accelerating the process of dissolution in a feedback loop of letting go. This mass loss is the star's protection against a more violent end, as it sheds enough weight to avoid the catastrophic collapse that leads to a supernova. The giant is effectively choosing a path of peaceful fading over a path of explosive destruction. By surrendering its mass to the wind, it ensures that its core will eventually settle into a stable, quiet retirement as a white dwarf. The shedding is a necessary shedding of burden, a paring down of the physical self to reach the essential, crystalline heart that remains. The expelled material does not simply disappear into the dark, but instead creates a massive glowing envelope around the dying star. This shroud of gas and dust can extend for several light years in every direction, forming a colossal, spherical cemetery of the star's own making. It reflects the giant's inner light, glowing with a faint ghostly luminescence that can be seen by infrared eyes across the galaxy. This circumstellar envelope is a layered archive of the star's mass loss history, with different shells of material representing different pulses of the giant's breath. It is a vast, translucent monument that honours the star's former glory while simultaneously hiding its current state. From a distance, the giant appears to be shrouded in a veil of rubies and smoke, a majestic and ethereal presence in the deep dark. Inside this glowing envelope, the environment is surprisingly calm, a sheltered pocket of space where the star's harsh radiation is tempered by the density of the dust. it is a place of transition, where the fierce energies of a sun are slowly translated into the quiet chemistry of the interstellar medium. This envelope is the protective womb in which the first molecules of a new era are allowed to form. If we were to look closer at the chemistry of this expanding cloud, we would find a complex environment where atoms find the peace needed to bond into something new. Molecules of water and carbon monoxide can form in these cool, expanding outflows, protected from the star's harshest rays by the shielding effect of the dust. This cooling mist is a chemistry lab on a galactic scale, where the building blocks of planetary atmospheres are assembled for the very first time. The hydrogen exhaled by the star finds oxygen forged in the core, and in the cool shadows of a dusk rain, they snap together to form the very first droplets of celestial water. Carbon and oxygen collide to form the stable bonds of carbon monoxide, creating a molecular signature that astronomers can trace across the light years. These are the same molecules that will one day fill the oceans of a distant planet, or the lungs of a living being. This molecular formation is a profound victory of order over chaos, a sign that even in the death of a star, the universe is constantly moving toward greater complexity. The red giant provides the nursery, the raw materials, and the shielding necessary for this delicate alchemy to occur. The breath of the giant is, quite literally, the breath of life in its most ancestral form. Let your breath be as effortless as the stars, knowing that your own existence is a part of this ancient interconnected cycle of stardust. This steady, rhythmic breath of the giant ultimately seeds the interstellar medium with the raw materials needed for future worlds and the lives that may inhabit them. Every atom of carbon in a blade of grass or oxygen in a human lung was once part of this slow, crimson exhalation into the deep dark. As the wind finally merges with the vast cold clouds of the interstellar medium, the story of the individual star ends and the story of the next generation begins. The atoms that once vibrated with the heat of a red giant's core now wait in the silence, ready to be pulled together again into a new sun. The breath of the giant is the bridge between what was and what will be, a continuous cycle of stardust that knows no beginning and no end. This bridge between eras is paved with a literal shift in the geography of life and warmth. As a star expands into a red giant, its habitable zone, that narrow band of space where liquid water can exist, migrates outward into the cold reaches of its system. Places that were once frigid cemeteries of ice are suddenly brushed by the long reach of the star's growing luminosity and the immense output of infrared energy. The boundary that once defined the limits of biology is pushed further into the dark, reclaiming frozen real estate for the potential of liquid life. This movement is a slow, relentless wave of heat that rolls over the outer planets, fundamentally reordering the thermal hierarchy of the entire solar family. A distance that once meant certain death by absolute zero now offers the perfect temperature for the delicate, complex dance of liquid water. The star, in its final expansion, is effectively redrawing the map of its own influence across the void. It reaches out to touch worlds it has ignored for billions of years, bringing them into its warm embrace for a final fleeting act of hospitality. This migration of the habitable zone is the first sign that the star's death is not just an ending, but a relocation of cosmic possibility and chemical potential. Surprisingly, this shift transforms the very identity of the outer worlds in ways that were previously unimaginable. Frozen wastelands that once orbited in eternal darkness and silence suddenly find themselves bathed in an intense, pervasive warmth. The distant, dim pinprick of a sun they once knew has become a massive ruby-coloured dome dominating their skies and radiating a fierce thermal energy. For billions of years, these distant orbits were the domain of absolute zero, where methane froze into solid rock and nitrogen fell as snow. Now, the atmosphere of the red giant provides a flood of photons that cuts through the ancient chill with ease. The dark, lightless plains are replaced by a world of glowing, orange-tinted horizons as the star swells to fill the firmament with its majestic presence. This sudden influx of energy is a shock to the planetary system, a thermal awakening that disrupts the long-standing order of the deep freeze. The energy doesn't just illuminate the surface, it penetrates deep into the crust of these forgotten bodies, stirring atoms that haven't moved since the system's birth. It is a fundamental reassignment of roles, where the outcasts of the solar system become its central protagonists under the light of the dying sun. If we were to look closer at these distant outposts, we would witness a spectacular planetary softening of the ancient crust. Moons made of solid ice, much like Europa or Enceladus, begin to feel the relentless touch of the giant's heat, causing their frozen surfaces to groan and fracture. Beneath the ruby light, these crystalline shells melt away to form global oceans of liquid water that shimmer under the vast red orb. The ancient ice, which stood as a permanent monument to the cold for eons, yields to the slow, persistent melting from the star above. Vast glaciers move with a newfound fluidity, sliding into deep valleys and filling ancient impact craters with the first liquid the world has ever known. The sensory reality is one of cracking rime, hissing steam, and the soft, rhythmic lapping of waves against the dark, rocky shores. A world that was once a silent white sphere of frozen gas is transformed into a shimmering deep blue eye reflecting the crimson star above. This transition from solid to liquid is the ultimate sign of the star's shifting warmth, a tangible proof of its changing nature. The ice becomes the womb for a new kind of liquid history, born in the final twilight of the sun. As you lie here, your muscles letting go of the day's tension, picture a temporary springtime blooming in the absolute twilight of a solar system's long life. This is not the green, budding spring of a youthful world, but a deep, resonant awakening occurring billions of miles from the star's original heart. It is a brief, beautiful reprieve for worlds that spent eons in the shadow of absolute zero. The warmth reaches out to the most distant moons of the gas giants, melting the methane frosts and thawing the nitrogen plains into a thick, misty atmosphere. In this strange, late-life spring, the sky is never truly dark, as the enormous red sun hangs perpetually over the horizon like a guardian of the deep. The very air, once frozen solid against the ground, begins to stir and circulate in the first winds these planets have felt in an eternity. This late bloom is a testament to the star's generosity, a final gift of heat before the light goes out forever. It creates a surreal, beautiful landscape where the red light of the dying sun glints off the surface of newborn lakes. This is the star's last masterpiece, a garden of warmth planted in the deep dark of the outer system to honour the end of an era. Deep within these newly liquid oceans, the conditions for complex molecular interactions finally align in a perfect synchronicity. For a few million years, these thawed worlds might provide a brief, isolated haven for complex chemistry to explore its own potential. The warmth is sufficient to stir the dormant chemicals, allowing them to dance and bond in ways that were impossible during the long icy night. Carbon and nitrogen, once trapped in the frozen lattice of the crust, are now free to dissolve into the warming water and interact with the elements. They collide and combine under the influence of the star's radiation, forming the precursors to the more complex structures that define the origins of life. This period of chemical exploration is a frantic, beautiful attempt at organisation in the face of the coming dark. Though the time is short by cosmic standards, it is long enough for a profound molecular evolution to take place within the deep. The star provides the energy, the water provides the medium, and the ancient ice provides the raw materials for this final, ambitious experiment. It is a brief, high-energy flourish of complexity, a signature of the star's creative power even in its inevitable decline. However, this gift of life to the outer reaches comes at a terrible cost to the inner sanctum of the system. Planets that were originally hospitable and teeming with their own history are simultaneously scorched into barren, airless cinders by the encroaching stellar surface. The same light that awakens the moons of the gas giants turns the cradles of early civilizations into molten wastelands of glass and stone. As the red giant expands, it consumes the very space where stable environments once flourished for billions of years. The atmosphere of an inner planet is stripped away by the intense radiation, leaving only a scorched and blackened husk to face the heat. What was once a vibrant green world is now a hellish landscape of liquid rock, glowing with the same ruby light as its killer. The star's growth is a zero-sum game of heat and habitability, shifting the focus of the system at the expense of its ancient origin. This destruction is the necessary precursor to the awakening of the outer worlds, a redistribution of thermal energy that leaves the inner system in ruins. The cradle is burned so that the grave may bloom in the distant dark. Feel the calm stillness of your own breath, and notice how the changing light of the red giant casts long, distorted red shadows across these newly awoken liquid landscapes. Because the star is so physically immense, the perspective of light on a moon's surface becomes surreal and haunting. These shadows stretch for miles across the rippling waves of new seas, creating a visual environment of deep contrast and eternal sunset. The sun no longer appears as a small bright point in the sky, but as a colossal glowing wall that spans the entire horizon. This means the light comes from many angles at once, softening the edges of shadows but stretching their length to impossible proportions across the ground. The crimson hue saturates everything, turning the new oceans into pools of liquid gold and the rocky cliffs into jagged silhouettes of fire. This landscape exists in a perpetual red-tinted twilight, where the sun never truly sets or rises with any recognizable speed. The shadows crawl sluggishly across the terrain, mirroring the star's own slow, ponderous evolution toward its final form. It is a visual symphony of red and black, a world defined by the long, cooling reach of a dying giant. Notice how the celestial architecture itself begins to break down under the influence of this shifting warmth. Comets that had safely nested in the deep freeze of the outer system for eons now find themselves passing through an inner system that is significantly hotter. They begin to sublimate violently, their ancient ice turning instantly to gas and leaving massive glowing tails of vapour that stretch across the dark like ghostly ribbons. The sudden heat from the expanding star acts like a forge, melting the icy hearts of these nomadic wanderers as they approach the centre. They are stripped of their outer layers, releasing dust and gas that catch the ruby light and glow with a fierce, ethereal brilliance. This transformation turns the quiet, dark space between planets into a crowded, luminous gallery of celestial fireworks. The tails of these comets can span millions of miles, creating a web of glowing vapour that connects the distant, warming worlds. They are the visible evidence of the star's new reach, markers of the heat that is now penetrating the deepest corners of the planetary system. Each comet is a sacrifice to the star's growth, a small piece of the old order dissolving in the new, intense warmth. Notice the heavy, pleasant weight of your hands and feet as you realise that this shifting zone of warmth proves that even a star's death throes can create fleeting, miraculous oases of liquid water in the most unlikely of places. The universe shows a strange, persistent tendency to create the conditions for life even as it destroys its old foundations. It is a moment of profound cosmic irony, where the end of a star's stability is the very catalyst for a new, liquid beginning. These oases are the ultimate testament to the creative potential of stellar evolution, demonstrating that warmth can be found even in the heart of destruction. They are small, temporary pockets of possibility that exist only because the star is dying and expanding its influence. In this way, the red giant phase is not just a funeral, but a final, frantic blossoming of hidden potential. The existence of these worlds challenges our understanding of the life cycle of a solar system and the permanence of habitability. It suggests that the most interesting parts of a system's history might occur at its very end, rather than its stable beginning. These fleeting havens are the star's last word, a liquid echo of its former glory that rings out against the dark. Eventually, the star's resources are completely spent, and even this temporary ruby-coloured warmth begins to fade. As the giant moves toward its final collapse and transition into a white dwarf, the habitable zone retreats once more, leaving the new oceans to refreeze into silent ice. The brief springtime ends, and the system returns to a cold, crystalline stillness that will last for the rest of eternity. The liquid oceans that once shimmered under the red light are now locked back into a permanent frozen crust of solid gas. The chemistry that was beginning to stir in the warmth is silenced, and the long red shadows are replaced by the faint blue-white light of a tiny distant spark. The star has finished its work, and the system settles into its final icy retirement under the watchful eye of a dead sun. This cycle of warming and cooling is the heartbeat of a dying star system, a final pulse of energy before the dark takes hold. The shifting warmth was a gift, a temporary reprieve from the cold that defined the outer worlds for so long. Now, all that remains is the ice, holding the memories of the brief, red-tinged spring that once bloomed in the twilight. The shifting warmth was a gift, a temporary reprieve from the cold that defined the outer worlds for so long, yet the twilight of a star's existence offers a far more permanent and generative legacy for the future of the cosmos. While we often view the finality of a life cycle as a process of depletion, red giants function as the universe's primary factories for the element carbon, the indispensable foundation of all known organic life. Every carbon atom found in the delicate structures of a protein or the strong lattice of a diamond began its journey within these swollen ruby-toned suns. As the star expands, it moves away from the simple, clean burning of hydrogen that defined its long youth. It begins a more complex and alchemical phase, utilizing its immense gravitational pressure to fuse the products of its earlier life into the building blocks of something entirely new. This transition ensures that the star's legacy is not merely heat and light, but the physical matter required for the eventual blooming of biological complexity across the galaxy. Deep within the scorching and pressurized heart of the giant, a delicate and near impossible energetic dance occurs between the remnants of the star's original fuel. The triple alpha process serves as the core mechanism of this alchemy, requiring exactly 3 helium nuclei to collide with near-perfect timing to overcome their natural repulsion. In the frantic, high-energy environment of the core, these 3 particles must find one another in a brief, shimmering window of opportunity to fuse into a single carbon atom. This reaction is remarkably sensitive to the surrounding environment, occurring only when the internal temperatures reach a blistering 100 million degrees. If the conditions are even slightly off, the helium nuclei simply bounce away from one another, remaining as inert ash in the centre of the star. It is a masterpiece of quantum tunneling and nuclear resonance, a rare and exquisite coincidence of physics that allows the universe to move beyond the simplest elements. The star must maintain this precise thermal balance for millions of years to accumulate the carbon stockpile that will one day seed the galaxy. This hidden, microscopic choreography is the heartbeat of the alchemist's crucible, turning the chaotic energy of the core into the structural stability of heavy matter. Every atom of carbon in your own body is a direct survivor of this ancient and highly improbable nuclear dance. Sometimes, the alchemy within the core does not stop at the creation of carbon, as the intense heat of the furnace continues to drive even more complex mergers. If the temperature and pressure are sufficient, a 4th helium nucleus may successfully join a newly minted carbon atom in a second, subsequent embrace. This higher energy collision forges a shimmering atom of oxygen, adding yet another essential ingredient for life to the star's internal stockpile. This secondary process expands the star's chemical repertoire, preparing the cosmos for the eventual presence of liquid water and the breath of living things. The oxygen produced in these depths is the very same element that will one day fill the atmosphere of a distant world or dissolve into its warming oceans. It is a tiered system of creation, where the star builds upon its previous triumphs to create a library of increasingly complex materials. These oxygen atoms represent a further step toward the diversity that will eventually define the habitable universe. The star acts as a patient and deliberate chemist, layering the products of its fusion in concentric shells of elemental wealth. This hidden accumulation of oxygen ensures that the red giant's death will be the ultimate catalyst for the chemistry of life, far removed from the simple hydrogen fires of its youth. Allow your shoulders to drop and your muscles to loosen as you sink into a state of deep, undisturbed calm, much like the stillness of space that surrounds the star's turbulent interior. While the forge burns in the centre, the star utilises a massive internal transport system to share its newly minted treasures with the wider world. Deep convective currents act as a gargantuan celestial elevator, dredging the carbon and oxygen up from the hidden core and carrying them toward the distant surface. These plumes of superheated plasma are enriched with the products of the triple alpha process, moving through the star's vast interior in a slow and majestic turnover. Without this internal stirring, the heavy elements would remain forever locked in the core, hidden away from the rest of the galaxy in a dense and unreachable graveyard. The convection currents ensures that the star's internal alchemy becomes its external legacy, painting the atmosphere with the materials of future planets. This dredging process is a slow and relentless churning that takes thousands of years to complete a single cycle from the centre to the edge. It is a grand circulation of matter that turns the red giant from a simple sphere into a dynamic and self-enriching system. By the time these elements reach the surface, they're ready to be cast off into the void, fulfilling the star's role as a cosmic distributor. Surprisingly, this process of enrichment looks very much like a slow, deliberate poisoning of the star's own outer layers from a purely aesthetic perspective. Notice how the giant slowly pollutes its once pristine hydrogen atmosphere with the heavy, dark ash of its own nuclear fires. What was once a clear and vibrant stellar envelope becomes clouded and metallic, thick with the complex waste products of the star's final, desperate fuel cycles. This pollution is the exact mechanism by which the star prepares itself for its final act of dispersal. The accumulation of heavy atoms in the atmosphere changes the way light interacts with the gas, trapping more heat and driving the star to even greater states of expansion. The star is literally changing its own physical nature from the inside out, becoming a vessel of heavy, processed matter, rather than a simple sphere of burning gas. To an outside observer, this darkening of the atmosphere might seem like a sign of decay, but it is actually the star's greatest achievement. The ash is the treasure the universe has been waiting for, a concentrated dose of complexity that will eventually survive the star's dissolution. This internal contamination is the price of the star's alchemical success, a necessary darkening before the bright dispersal of its elements. In some rare and breathtaking instances, these giants become so saturated with their own internal material that they are reclassified as carbon stars. Their atmospheres become so incredibly rich with microscopic soot and heavy atoms that they filter out all but the deepest, most melancholic wavelengths of light. These celestial objects glow with a deep, haunting ruby red that is far more saturated and intense than the colour of an ordinary red giant. If we were to look closer, we would see that these stars are effectively shrouded in a thick cosmic smoke of their own making. The carbon in their atmosphere condenses into tiny solid grains, creating a veil that absorbs blue and yellow light with near-perfect efficiency. This results in a visual appearance that is often described as a blood red or ruby hue, standing out as a rare and exotic beauty in the night sky. These carbon stars are the most efficient alchemists of all, hoarding their soot until they are ready to breathe it out into the dark in one final, massive exhalation. They represent the extreme limit of stellar enrichment, a state where the star is more carbon than hydrogen in its outer reaches. Their presence is a vibrant reminder of the star's ability to completely reinvent its own identity through the power of nuclear fusion. This cosmic soot is not merely dead dust, but a collection of remarkably complex molecules forming in the cooling eddies of the stellar wind. If we were to look closer at the molecular structures within the outflow, we would find polycyclic aromatic hydrocarbons, large and complex organic molecules that mirror the chemistry of terrestrial life. These carbon-rich rings are the precursors to even larger structures, acting as the foundation for the organic chemistry that will one day populate the galaxy. Forming in the relatively cool outskirts of the giant, these molecules are shielded from the star's harshest radiation by the very dust they help to create. They drift away from the parent star as a delicate aromatic mist, carrying the instructions for complexity into the deep, cold clouds of the interstellar medium. These molecules are remarkably resilient, capable of surviving for eons in the vacuum as they wait to be incorporated into new solar systems. It is a startling realization that the same chemistry found in the soot of a campfire or the smoke of a guttering candle is also being manufactured in the winds of a dying sun. The red giant is not just making atoms, it is making the architecture of complexity itself. This molecular legacy is the star's most sophisticated gift, a toolkit of organic possibility cast into the dark. Feel the steady, comforting weight of your own limbs and the solidity of your frame as you rest, recognizing that the very materials that make you possible are products of this ancient cycle. The calcium in your bones and the iron in your blood owe their ultimate existence to these ancient stellar forges and the later stages of their evolution. While the red giant specializes in the lighter organics like carbon and oxygen, it is the essential first step in a chain of enrichment that leads to the metals of biology. Every hard surface in your body and every metallic transporter in your veins is a literal piece of a star that lived and died long before our sun was even a cloud of gas. The red giant's ability to forge these elements and then distribute them through its gentle breath is what allowed the universe to move beyond a simple, gaseous state into the realm of solid, complex bodies. You are a walking, breathing map of stellar history, a biological mosaic composed of the remnants of ancient nuclear furnaces. The connection is not metaphorical but physical, a direct lineage of atoms that has survived the destruction and rebirth of multiple stellar generations. The star's long ago struggle to fuse helium into carbon is what allows you to exist in this moment of quiet reflection. Your physical form is a testament to the alchemist's success, a living proof that the death of a star is the foundational act of all life. Every breath you take in this moment of deep relaxation contains atoms that were once cooked inside the pressurized and lightless furnace of a dying giant. The oxygen and nitrogen in the air surrounding you are not new. They are ancient recycled treasures that were exhaled by stars eons ago and left to drift through the galactic void. These atoms were gathered by the gravity of our young solar system, incorporated into the atmosphere of the Earth, and are now moving through your own biological systems. You are literally inhaling the debris of an ancient celestial transformation, bringing the cooling history of a red giant into your very lungs with every inhalation. These atoms have travelled light years, surviving the cold of the interstellar medium and the heat of planetary formation to find their way to you. They are the star's persistent presence in our world, an invisible cloud of history that sustains our every moment. This realization turns the simple act of breathing into a profound connection with the deep time of the universe. The air is not just a gas, it is a storied archive of stellar evolution, a physical link between your resting body and the ruby-coloured suns of the distant past. Each breath is a reminder that we are part of a continuous breathing cosmos that recycles its most precious materials in an eternal cycle of life and death. This structure of slow, inevitable decline is exactly what allows the universe to transition from a simple, monotonous sea of hydrogen into a place of profound chemical diversity. Without the red giant's ability to forge heavy elements and then distribute them through its gentle, outward-bound breath, the cosmos would remain a barren and uncreative expanse of basic gases. The slow death of the star is the price the universe pays for the complexity, beauty, and variety of every world that follows in its wake. The red giant phase is the ultimate turning point in the history of the galaxy, the moment where the universe finally learns to make things. It is the transition from the simple to the complex, from the singular to the diverse, and from the energetic to the structural. By letting go of its mass and surrendering its own life, the star ensures that the galaxy will be enriched with the raw materials of infinite possibility. This chemical diversity is the true legacy of the alchemist's crucible, a testament to the star's role as the great provider. We live in a world of colour, texture and life only because these ancient suns spent their final days cooking the dark into something new. The slow, crimson twilight of the red giant is the most productive and essential act in the entire history of the stars. This essential act of creation, occurring within the deep crimson twilight, eventually finds a rhythmic expression in the star's physical form. As a red giant matures, its entire structure becomes fundamentally unstable, causing many of these titans to transition into what we call mirror variables. These are stars that have moved beyond a static existence and have begun to literally pulsate in size and brightness, a visual testament to the raging internal pressures that no longer find a quiet equilibrium. The star is caught in a profound struggle between the inward pull of gravity and the outward push of its rejuvenated nuclear furnace. Because the outer layers are so tenuous and far from the core, they respond to these forces with a slow, ponderous motion that ripples across the entire stellar surface. This transformation into a variable star marks a departure from the steady, predictable light of the star's youth, replacing it with a mesmerizing and massive oscillation. To witness a mirror variable is to see a star that is no longer content to simply shine, but one that is actively breathing with the effort of its own survival. This pulsing is not a sign of health, but a symptom of a structure pushed to its absolute physical limits. It is a cinematic display of stellar mechanics, where the star's very boundary becomes a moving, heaving threshold between the furnace and the void. Surprisingly, this trapped heat acts as a propellant, forcing the atmosphere to swell outward in a grand, expansionary surge. As the gas expands, it thins out and becomes more transparent, finally allowing the pent-up radiation to leak out into the surrounding darkness. The loss of this internal pressure causes the star to cool and settle, eventually leading to a renewed collapse under its own gravity. This cycle, known to researchers as the Kappa mechanism, creates a self-sustaining loop of physical movement that defines the star's late-life identity. It is a delicate atmospheric engine, fueled by the paradox of matter that becomes more or less resistant to light based on its density. The star is effectively choked by its own substance until it pushes itself apart, only to fall back together and begin the process once more. Surprisingly, this gargantuan celestial machine operates on a time frame that mirrors the seasonal changes of a planet, rather than the rapid flickers of a younger sun. This cycle of swelling and shrinking takes place over vast periods, often spanning hundreds of days for a single complete pulsation. The star moves with a heavy, deliberate momentum taking months to reach its greatest extent before beginning the long, slow journey back toward contraction. The sheer physical distance covered during these cycles is absolutely staggering, often involving the movement of billions of tons of plasma across millions of miles. Because the star is so immense, the transit of energy and matter through its atmosphere cannot be rushed by the laws of physics. Each pulsation is a geologic scale event, a massive redistribution of heat that dictates the star's appearance for years at a time. As you feel the steady, reassuring weight of your own body resting in the silence, imagine the star executing this same slow rhythm across the light years. The time it takes for you to experience a year of life is roughly the same time the giant takes to complete a single heaving breath. This harmony of duration connects the biological clock of the observer to the final, rhythmic countdown of the stellar forge. Picture a glowing heart, beating with a heavy and unhurried pulse in the absolute silence of the deep void. This sensory focus reveals a solitary red light that does not merely twinkle, but grows and fades with a profound, almost sentient quality. At its brightest, the star dominates its local region of space with a fierce, ruby-toned intensity that casts long shadows across its planetary system. When the pulse reaches its minimum, the star retreats into a dim, brooding glow that makes it nearly invisible to the naked eye. This rhythmic dimming and brightening creates a visual signature that is unlike any other object in the night sky, a slow-motion flicker that spans the seasons. It is a lighthouse of the deep dark, warning of the intense physical changes occurring within the heart of the giant. The light we perceive is the star's voice, a rhythmic broadcast of its internal struggle against the coming dark. Each period of brightening is a victory of internal energy over the shrouding atmosphere, a brief flare of brilliance before the inevitable retreat. Watching this heartbeat is a humbling experience, a direct observation of a star's final, frantic attempt to maintain its place among the heavens. At the moment of maximum expansion, the star's surface reaches its lowest temperature, allowing a strange and beautiful chemistry to occur in the thinning gas. The cooling atmosphere reaches a critical point where microscopic grains of carbon and silicate can finally condense out of the cooling plasma. This process turns the outer layers of the star into a thick, opaque veil of dust that temporarily obscures the star's own light. This shroud acts as a dark blanket, absorbing the visible photons and re-radiating them as heat, which causes the star to appear significantly dimmer to an outside observer. The giant is effectively hiding behind a wall of its own making, a dusty cocoon that marks the outer limit of its expansion. During this phase, the star becomes a ghost of itself, a massive and dark presence that lingers in the infrared. Notice how the creation of solid matter is fundamentally tied to the star's physical movement. The expansion is the cooling mechanism that allows the dust to survive, turning the gaseous sun into a producer of solid debris. This period of darkness is the most chemically productive time in the star's life, as the cooling winds become a nursery for the first grains of a future world. As the star begins to contract, the underlying heat is no longer trapped behind the veil of its own inflation, and the temperature of the gas begins to skyrocket once more. This rising heat is lethal to the newly formed dust grains, causing them to sublimate and vanish back into a gaseous state. As the dust disappears, the atmosphere clears, allowing the star's internal brilliance to flare out into the void with renewed intensity. This sudden clearing of the stellar air causes the star to brighten dramatically, sometimes by several magnitudes in a matter of a few weeks. The star emerges from its dusty shroud like a fire being stoked, shedding its dark mask to reveal the fierce ruby furnace beneath. It is a moment of spectacular visual rebirth, a flash of energy that washes over the surrounding planets and comets. This cycle of dust formation and destruction is a continuous cleansing of the star's outer atmosphere. Each pulsation resets the chemical stage, preparing the environment for a new generation of dust during the next expansion. The star is caught in a perpetual dance between the solid and the gaseous, a rhythmic transformation that dictates the colour and clarity of its escaping light. These powerful pulsations are far more than just a visual display. They're a source of immense kinetic violence that ripples through the stellar envelope. As the star heaves in and out, it generates massive low-frequency shock waves that propagate from the deep interior to the absolute edge of the atmosphere. These waves act like a celestial hammer, striking the tenuous gas and driving it outward with a force that gravity can no longer counteract. The shock waves provide the final, necessary push that accelerates mass loss, turning the star's gentle breath into a more active and efficient shedding of self. Each pulse effectively kicks a layer of the star into space, launching millions of tons of carbon and oxygen into the interstellar medium. It is a rhythmic ejection of material, a pulse delivery system that ensures the star's elements are spread far and wide. Take a moment to let the stillness of your surroundings sink in, noticing the absence of such violent forces in your own immediate environment. While the star is a scene of shockwaves and kinetic fury, you are a safe observer of its distant and beautiful dissolution. The energy that drives these waves is the very same energy that will eventually leave the star as a quiet, cooling core. The rhythm of these variations is so incredibly consistent that it has reached across the light years to touch human history in profound ways. Ancient astronomers and stargazers noticed these wonderful stars that appeared and disappeared from the night sky with a predictable and reliable timing. The star Mira, the namesake of this class, was documented centuries ago as a celestial mystery that challenged the idea of a perfect and unchanging cosmos. Because the periods of these stars are so precise, they were used by early observers to track the passage of time and the cycles of the year. A star that takes exactly 332 days to return to its maximum brightness acts as a natural cosmic clock. It is a testament to the reliability of stellar physics that even a star in its death throes can maintain such a rigorous and steady beat. This historical connection reminds us that we have been watching the heartbeat of red giants for as long as we have been looking at the stars. Their variations have been woven into the calendars and myths of diverse cultures, acting as markers of the deep time that governs the universe. The star's final rhythm has become a part of our own human story, a pulse that we share across the generations. Each beat of this cosmic heart acts as a forceful pump, driving the star's alchemical treasures deeper into the surrounding dark void. The pulsations are the mechanism of distribution, ensuring that the carbon and oxygen forged in the core do not stay locked within the stellar interior. With every swell and contraction, the star is effectively breathing its lifeblood into the galaxy, enriching the interstellar medium with every rhythmic gasp. This redistribution is a selfless act of cosmic stewardship, where the star's final energy is used to propel its physical legacy away from its own grave. The carbon that will one day form the basis of organic molecules is carried on the back of these atmospheric shockwaves. Without the heartbeat, the star's elements would remain a hidden and useless hoard. With it, they become the seeds of the future. This process ensures that the death of a red giant is the most generative event in the chemical history of a galaxy. Each beat is a contribution to the diversity of the universe, a rhythmic payment of the star's accumulated wealth to the void. The heart of the giant is the pump that fuels the ongoing evolution of the cosmos, turning stellar ash into the foundation of new life. This pulsing phase is an unmistakable signal, a final warning that the star is rapidly approaching the absolute end of its active life. The instability that drives the pulsations is a symptom of a star that has run out of its most efficient ways to manage its energy. It is the final, high-energy flourish of a sun that is about to shed its entire outer identity and leave behind a naked, cooling core. Astronomers recognize this phase as the star's last stand, a brief and spectacular epoch that precedes the formation of a planetary nebula. Once the pulsations reach their peak intensity, the star will soon lose so much mass that the remaining envelope will simply drift away, exposed to the intense ultraviolet light of the inner core. The heartbeat is the countdown, a rhythmic tally of the days remaining before the star's light is transformed forever. This realization brings a sense of poignancy to the observation of a Mira variable as we are witnessing a star in its final, frantic moments of glory. The beauty of the pulse is tempered by the knowledge of its ending, a reminder that every life cycle must eventually reach its conclusion. The star's heartbeat is a magnificent terminal rhythm, a final song of light before the silent white stillness of the end. Before that silent white stillness of the end arrives, the star surrounds itself with a protective and complex shroud of its own making. The dust expelled by a red giant often forms asymmetrical shells that hang in the void like a series of translucent ghostly veils. These structures are rarely perfect spheres, as the erratic nature of the star's final pulsations pushes material out in uneven, jagged bursts that reflect the chaotic energy of the core. As the star heaves, it ejects matter with varying speeds and densities, creating a layered architecture that records its recent history in the most minute detail. One region might be thick with carbon soot, while another remains a tenuous mist of hydrogen gas drifting slowly away from the core into the infinite cold. The gravitational instability of the bloated star ensures that this outward-bound debris is scattered into a fractured and beautiful geometry that defies simple spherical models. This cosmic debris is not merely waste, but a complex environment where the star's cooling history is written in the dark using atoms as ink. These shells can span light years, stretching out like the ripples in a pond that have been frozen in time for an eternity. They represent the first physical boundary between the individual identity of the star and the anonymous expanse of the interstellar medium, a final expansion before the quiet finish. Surprisingly, this celestial graveyard is not as lonely or chaotic as it might first appear. Invisible planetary companions, often hidden by the star's overwhelming brilliance, can sculpt this escaping dust into intricate spirals and rings. As these worlds orbit the dying giant, their gravitational wake acts like a massive spoon stirring a thick cosmic broth, twisting the stellar wind into spectacular shapes. This gravitational sculpting turns a simple outward expansion into a masterpiece of celestial choreography. A planet or a smaller binary star can carve deep grooves into the dust shells, creating nested spirals that wind through the darkness for trillions of miles. These shapes are evidence of a hidden partnership, a final dance between a parent star and the children it once nurtured. The resulting structure looks like a cosmic phonograph, where the spiral grooves are a recording of the system's final movements. The dust records the orbital path of these companions with incredible precision, acting as a high-contrast medium that reveals the unseen. Even planets that are far too small to be seen directly leave their signature in the way the silicates are distributed. It is a hauntingly beautiful realization that the star's very last moments are used to highlight the presence of the worlds it will eventually leave behind. This structure eventually becomes so dense that the star effectively constructs its own visual prison. These stellar cocoons can become so thick and opaque that the central star is completely hidden from visible light telescopes. What was once a brilliant ruby beacon in the night sky disappears behind a wall of its own making, leaving only a dark, brooding silhouette in the void. The soot and silicates act as a perfect barrier, absorbing the star's light and scattering it in every direction, until nothing of the original source remains. For an observer using only the eyes, the star has effectively died already, swallowed by a cloud of smoke and ash that it exhaled over the course of millennia. This phase represents a transition into a state of deep, hidden transformation. The cocoon acts as a thermal blanket, trapping the star's intense internal heat and re-radiating it into the dark as a soft infrared glow. It is a place of profound isolation, where the giant is cut off from the rest of the galaxy by its own physical legacy of smoke and ash. Inside this dark womb, the final stages of the star's life proceed in secret, away from the prying eyes of the visible universe preparing for its ultimate revelation. If we were to look closer using instruments that transcend the limitations of the human eye, the star's hidden presence would be revealed in vibrant detail. Astronomers must use infrared vision to peer through the warm soot and see the giant within its dusty tomb. Because infrared light has longer wavelengths than visible light, it can slip between the microscopic grains of dust as if they were nothing more than a thin mist. This infrared light is essentially the heat of the star's core radiating out through the debris and allowing us to see the ghost of the star that still burns inside. Using these specialized tools, the opaque wall of the cocoon becomes transparent, revealing a frantic and boiling surface that is still very much alive. It is like looking through a thermal camera at a fire buried under a pile of rubble. The universe in the infrared is a landscape of warmth rather than light, and the red giant is its most spectacular resident. These observations allow us to measure the star's temperature and size even when it is physically impossible to see its surface directly. It is a reminder that the most important parts of a star's life often happen in the shadows, where only the patient and the prepared can find them. Imagine a glowing ember buried deep within a mound of dark, smoky ash, radiating a heat that the eyes cannot see, but the universe can feel. This sensory metaphor perfectly describes the state of a red giant during its most intense period of mass loss. The star is no longer a bright point of light, but a diffuse and powerful source of thermal energy that permeates the surrounding space. The ash of the star's past, the carbon and silicates, has become a thick, insulating layer that protects the remaining core from the cold. Beneath this mound of debris, the nuclear furnace still rages, stubbornly fighting against the inevitable cooling of the outer atmosphere. The light that manages to escape is no longer a sharp beam, but a soft, pervasive warmth that fills the cocoon with a dull crimson glow. This hidden state is one of the most productive phases of the star's life, as it builds up the materials that will eventually form the foundations of new systems. The ember is the source of all the complexity that follows, a concentrated point of energy that refuses to go out. It is a quiet, powerful endgame where the star's internal fire is slowly but surely translated into the physical architecture of the future. Deep within these expanding veils, the individual grains of dust are incredibly tiny, possessing a scale that contradicts their massive collective influence. Most of these particles are silicates and carbon soot, similar in size to the microscopic particles found in cigarette smoke. They are the building blocks of the material world, forged in the cooling breath of the dying giant. As you feel the gentle, rhythmic weight of your resting body, consider the near weightlessness of these trillions of particles drifting through the dark. Despite their individual insignificance, their sheer numbers allow them to manipulate the light of an entire star and seed the galaxy with solid matter. They are the dust of history, the microscopic grit that will one day clump together to form the crust of a planet. The sensory reality of this environment would be one of a faint shimmering haze, where each grain of dust catches and reflects the ruby light of the core. This is the star's most tactile legacy, a physical substance that can be touched and measured across the light years. The tiny scale of the grains is the secret to their success, allowing them to be carried on the wind of starlight into the furthest reaches of the void. Surprisingly, the universe uses these microscopic particles to perform a spectacular display of light manipulation that tells a story of alignment and force. When starlight hits this dust, it produces a beautiful, scattering effect known as polarization. The photons do not merely pass through the veil, they are bounced and filtered by the grains, emerging with a specific orientation that astronomers can measure. This polarization turns the light into a map of the star's magnetic fields and the orientation of its dust shells, providing a visual guide to its internal structure. It creates a shimmering, iridescent quality to the light that is often invisible to the naked eye, but contains the structural secrets of the star's envelope. The light is no longer a simple broadcast, but a textured and complex signal that has been shaped by its passage through the gritty stardust. This scattering effect is what gives many astronomical images their soft, ethereal glow, as if the star were surrounded by a halo of liquid light. It is a visual testament to the interaction between energy and matter, where the light itself is modified by the substance it encounters. The polarization is the star's final signature, a refined and filtered version of its original brilliance. Notice how your own history is recorded in the layers of your memory, just as the star records its own life in the geometry of the surrounding void. Some giants exhibit detached shells of dust, indicating clear periods where the star stopped losing mass before starting again. These gaps in the dust work much like the rings of an ancient tree, providing a chronological record of the star's erratic and pulsing life cycle. A detached shell represents a moment of relative calm, where the star's internal pressure subsided and the exhalation of dust briefly ceased. The previously ejected material continued to drift away, creating a hollow sphere of emptiness before the next pulse of mass loss began. By measuring the distance between these shells, researchers can calculate exactly how much time passed between the star's different eras of shedding. The chemical makeup of this shimmering dust acts as a forensic record that tells astronomers exactly what is burning in the unseen core. By analysing the light that filters through the veil, we can determine the ratio of carbon to oxygen and the presence of specific metallic isotopes. This chemical fingerprint reveals the deep, internal alchemy of the giant, even when we cannot see the core directly. If the dust is rich in graphite and complex hydrocarbons, we know the star has successfully dredged up carbon from its deepest nuclear furnace. If the grains are primarily silicates, it indicates a star where oxygen fusion has dominated its final internal stages. The dust is the messenger, carrying the secrets of the star's internal state out into the light for us to decipher. This forensic science allows us to understand the life cycle of the star and predict its final end with incredible accuracy. The grains of dust are the physical evidence of the star's success as an alchemist, a tangible proof of its internal transformation. This chemical archive ensures that even after the star has vanished, its contribution to the galaxy's elemental wealth will be known. This dusty veil will eventually expand to become the majestic glowing clouds we call planetary nebulae, the final and most beautiful monuments of a star's life. As the red giant sheds its last layers, the hot, naked core is finally exposed, flooding the surrounding debris with intense ultraviolet radiation. This high-energy light causes the dust and gas to glow with brilliant iridescent colours that span the entire visible spectrum. The transition from a dark, dusty cocoon to a vibrant planetary nebula is one of the most dramatic transformations in the universe. The previously hidden shells and spirals are suddenly illuminated, revealing the complex geometry that the star spent millennia sculpting in the dark. The dust that was once a prison for the star's light now becomes the medium for its most spectacular final display. These glowing clouds will continue to expand for thousands of years, eventually dissolving into the interstellar medium to provide the raw materials for new stars. The planetary nebula is the star's final exhalation, a magnificent cloud of light and matter that marks the absolute end of its individual journey. It is a beautiful and expansive legacy, a final gift of colour to a universe that is otherwise filled with dark and cold. This individual journey, however, is not always a solitary passage through the frozen dark. While we often envision these titans drifting alone in their crimson majesty, the reality of the cosmos is far more social and interconnected. Many red giants do not die in isolation, but share their orbits with smaller, much denser companions like white dwarfs. These tiny, hot remnants of previous stellar generations linger in the gravitational embrace of the expanding giant, waiting for the moment when their paths will inevitably cross. This proximity creates a complex gravitational relationship that fundamentally changes the way the giant experiences its final days. Far from being a lonely exit, the death of such a star becomes a collaborative effort of physics. The presence of a companion ensures that the star's matter is not just lost to the void, but actively managed by a secondary force. It is a shared history where the fate of one star is inextricably tied to the proximity of the other. The giant star's expansion becomes a bridge to another entity, weaving their futures into a single, complicated tapestry. They exist as a unit, a binary system where the death of one fuels the continued activity of the other. This social arrangement is common throughout the galaxy, turning solitary deaths into complex stellar interactions. As the red giant continues its relentless outward expansion, its tenuous outer atmosphere eventually reaches a critical tipping point. The gas at the furthest edges of the star finds itself caught between two competing gravitational masters. Eventually, the outer layers of the giant begin to spill over into the powerful gravitational well of its nearby neighbour. This is a quiet, persistent theft of matter, as the giant effectively bleeds its own substance onto the compact companion. The white dwarf acts like a celestial vacuum, drawing the ruby-coloured plasma across the light years to feed its own intense density. This transfer of mass occurs because the giant has outgrown its own ability to hold onto itself. It is a slow, rhythmic draining of the stellar envelope that can last for thousands of years. The smaller star's gravity is so intense that it literally peels the surface off its larger sibling. This process creates a bridge of plasma that connects two entirely different stages of stellar life. The stolen material forms a stream that moves with relentless purpose toward the waiting neighbour. It is a visual representation of mass loss that is far more targeted than the general stellar wind. The giant is slowly consumed by the companion it once held at a safe distance. As your breath remains slow and rhythmic, matching the ancient cycles of the heavens, the steady accumulation of matter on the white dwarf reaches a point of catastrophic instability. Occasionally, the layer of hydrogen and helium stolen from the giant is crushed against the surface of the dense companion until it reaches the threshold for nuclear ignition. Suddenly, the accumulated gas on the white dwarf ignites in a sudden, brilliant nova explosion that can outshine the entire galaxy for several days. This is a surface-level detonation, far more rapid and visible than the slow pulsations of the giant's core. It is a periodic, violent cleansing of the companion's surface, a flash of energy that blasts a portion of the stolen material back into the void in a wave of blue-hot fire. These outbursts can occur repeatedly over the lifespan of the binary system, acting like a recurring cosmic flare. Each explosion carries away a fraction of the matter, but the core of the companion remains unharmed. The giant simply continues to feed the white dwarf, setting the stage for the next ignition. It is a cycle of theft and explosion that defines the terminal era of the star. The light from a nova is a signal to the rest of the galaxy that the symbiotic dance is reaching its peak. These events provide a spectacular, flickering counterpoint to the giant's steady red glow. Picture a bloated crimson sphere quietly bleeding its outer atmosphere onto a tiny, fierce blue point of light. The visual contrast is staggering, a clash between the soft, diffuse warmth of the red giant and the concentrated, pinpoint fury of the white dwarf. Where the stream of stolen plasma strikes the accretion disk, it creates a hotspot of incredible friction and turbulence. This area screams with radiation as kinetic energy is converted into heat, carving a bright, incandescent wound into the fabric of the swirling disk. It is a scene of beautiful, violent asymmetry, where a giant's gentle breath becomes a lethal, high-velocity jet. The blue-hot friction marks the exact point where two stellar destinies collide and merge. This interaction is the sensory heart of the binary system, a place of intense, localized violence. The red light of the giant is swallowed by the blue-white glare of the collision. It is a visceral reminder of the power contained in these gravitational interactions. The friction acts as a barrier, heating the incoming gas to temperatures that are impossible on the star's surface. It creates a localized sun that burns with a different, more frantic fire. The sheer intensity of this meeting point highlights the physical struggle at the center of the symbiotic relationship. The companion is not merely a passive recipient of matter, but a powerful engine of radiation in its own right. The intense ultraviolet radiation from the companion can ionize the giant's slow-moving wind, stripping electrons from the atoms and causing the gas to glow. This radiation pressure and ionization sculpt the surrounding debris into complex, multi-layered nebulous shapes that would be impossible for a solitary star to create. We see bipolar lobes, intricate rings, and glowing filaments that trace the intersection of the two stars' influence. The companion acts as a celestial sculptor, using its harsh light to carve the giant's final exhalation into a masterpiece of glowing geometry. This process turns the dark, dusty envelope into a vibrant and colourful display of celestial art. The UV light provides the energy needed to illuminate the chemistry of the star's breath. It reveals the presence of oxygen, carbon and nitrogen in vivid detail across the void. The resulting nebula is a signature of the partnership between the two stars. The light from the companion breathes life into the dead dust, turning it into a glowing ghost of the star's former identity. This ionization is the key to seeing the true structure of the mass loss. It turns the invisible wind into a visible monument of the symbiotic dance. Deep within this gravitational choreography, the companion can also act like a massive propeller, spinning the giant slow wind into a fast equatorial disk. As your mind follows these complex orbits, allow your own muscles to relax, finding a steady and grounded stillness far from the star's motion. Because the white dwarf moves through the giant's atmosphere at such high speeds, it drags the surrounding gas into a swirling wake. This turns a once uniform exhalation into a focused high-velocity stream that concentrates matter in the orbital plane of the two stars. The result is a system that looks like a glowing red hub with a sharp, thin ring of matter cutting through its center. This equatorial disk eventually becomes the foundation for some of the most spectacular planetary nebulae in the galaxy. The propeller effect ensures that the star's mass is not distributed equally in all directions. It creates a preference for the equator, resulting in a flattened and highly structured distribution of matter. This is the star's way of organizing its own debris before the final finish. The spinning motion adds a layer of kinetic energy to the gas, helping it escape the giant's gravity. It is a powerful example of how a small companion can dictate the large-scale structure of a dying star. The propeller creates order out of the star's chaotic breathing. In some extreme and terrifying cases, the drag from the companion's orbit becomes so great that its path begins to decay. The smaller star may actually plunge inside the red giant's bloated outer envelope, spiraling toward the core through a thick sea of hot plasma. This starts a frantic race against time, as the companion's kinetic energy is transferred into the giant's atmosphere, heating it to incredible levels. The two stars effectively share a single, massive skin for a brief, violent epoch of common existence. This internal friction creates a massive outpouring of light and heat that can be seen across the entire local group of galaxies. It is a process of total atmospheric engulfment that can strip the giant of its layers in a matter of months. The companion acts like a hot iron moving through a mountain of ice, melting and scattering everything in its path. This is the common envelope phase, the most violent interaction possible in a binary system. It is a moment of total unity before the final separation. The energy released by the plunge is so vast that it can eject the entire stellar envelope into space. This represents the ultimate climax of the symbiotic dance. The star is literally torn apart from the inside out by its own companion. If we were to look closer at the aftermath, we would see that this violent common envelope phase dramatically alters the fate of both stars, often leaving a tight binary pair behind. The friction of the plunge can strip the giant of its entire outer atmosphere in a single catastrophic event, exposing the core much earlier than normal. What remains is a pair of stellar remnants, a new white dwarf and its companion, orbiting each other in a matter of hours rather than years. This process is the primary mechanism for creating the universe's most exotic and compact systems, including those that will eventually produce Type 1a supernovae. The symbiotic dance concludes with a radical reorganization of matter, ensuring that the legacy of the red giant is one of high energy proximity and future explosions. The two stars are now locked in a permanent tight embrace, forever changed by their brief period of shared atmosphere. Their orbits are now so close that they can influence each other's gravity more than ever before. This new state of existence is the final, hard-won prize of their long interaction. It is a compact and powerful ending to a system that once spanned the sky. The remnants will spend the rest of their lives in this tight formation, a testament to the violence of their history. This final state is the ultimate legacy of the symbiotic dance. The ultimate legacy of this cosmic dance is a state of existence where the very laws of nature seem to fold upon themselves, in a magnificent display of structural contradiction. A red giant is fundamentally a star caught in a paradox of simultaneous collapse and expansion, a celestial entity that is falling inward and flying outward in the same breathtaking moment. This struggle is the defining tension of its later life, a battle between the crushing weight of gravity and the frantic, desperate pressure of a dying core. This physical duality means that the star is never truly at peace, but is instead a vibrant and restless monument to the power of competing forces. Every square mile of its surface is a testament to the internal war being waged between the core and the envelope. To look upon a red giant is to witness the absolute limit of what a star can endure before it is forced to choose a final, quiet path. At the outermost edges, the gas has drifted so far from the furnace that it begins to settle into a deep, melancholic chill, reaching temperatures that allow solid dust to survive. Yet, only a few 100,000 miles beneath this cool shroud, the core has shrunk into a white-hot ember, reaching 100 million degrees. This star is a kingdom of ice and fire, where the frozen silence of the void meets the screaming fury of nuclear fusion in a single, unified body. The cool exterior is the mask the star wears to hide the terrifying intensity of its heart. It is a protective, ruby-toned veil that softens the star's presence in the night sky, even as its center prepares for a final, catastrophic transformation. This internal heat is the engine of the star's growth, even as its surface prepares for the final cooling of the interstellar dark. This structure of deception continues as the star enters its final, most luminous era. The giant appears to be growing more powerful, outshining its younger self by thousands of times, yet it is actually running out of fuel and nearing a total energy bankruptcy. It is a spectacular and brilliant facade, a flare of light that masks the fact that the star has exhausted its primary resources and is now burning through its final precious reserves. The immense luminosity is not a sign of vitality, but a symptom of the star's desperate attempt to maintain its size against the encroaching dark. As the core burns through helium at an accelerated rate, it pours out a staggering amount of energy that inflates the star to its maximum extent. This brightness is a warning, a final radiant broadcast that the star's internal clock is ticking toward a silent conclusion. Every photon that leaves the surface is a piece of the star's finite future, cast into the void with a reckless and beautiful intensity. This illusory power is what makes red giants the beacons of the ancient galaxy, standing out as the brightest stars in the oldest clusters. They achieve their greatest glory at the precise moment they are most vulnerable, turning their inevitable decline into a masterpiece of light. If we were to look closer at this process of dissolution, we would see an act of profound cosmic generosity. By shedding its outer layers in a gentle and continuous breath, the star ensures its own destruction while providing for future generations of planets. The very material that was once its identity is cast off into the dark to become the building blocks of worlds that have not yet been imagined. The star does not hoard its riches, but allows its atmosphere to slip away, seeding the interstellar medium with the carbon and oxygen it spent eons forging. This mass loss is the mechanism by which the universe moves forward, recycling the old to make way for the new. The giant sacrifices its own physical integrity to enrich the void, turning its final expansion into a gift of matter to the coming eras. This shedding of the self is a necessary part of the galactic metabolism, a transfer of elemental wealth that fuels the birth of future suns. The star's end is not a waste, but a redistribution of potential that will eventually settle into the crust of a new Earth. It is a cycle of destruction and provision that ensures the cosmos never truly runs out of the ingredients for complexity. Notice the quiet rhythm of your own heart as it beats within the safety of this material world. As you rest here, fully supported by the ground beneath you, realize that the seemingly violent process of a star's death is ultimately what makes life possible. The carbon in your DNA and the oxygen in your breath are the direct results of this ancient and turbulent stellar ending. The universe requires the dissolution of these massive red suns to create the chemical diversity necessary for biological existence. Without the red giant's expansion and subsequent shedding, the raw materials of your physical form would remain forever locked in the unreachable depths of a stable sun. Your very existence is a testament to the success of this alchemical process, a living echo of a star's final generous exhalation. The death of the giant is the prerequisite for the birth of a person. We are part of this cycle of transformation, inextricably linked to the ruby-coloured light that once filled the sky of an ancient solar system. This realization turns the star's end into a moment of profound connection, a biological legacy written in the stars and realized in our own beating hearts. Deep within the heaving mass of the star, a silent and organized transformation is taking place beneath the chaotic exterior. The chaotic, boiling surface hides a center that is quietly transforming into an ultra-dense crystal of carbon and oxygen. While the atmosphere rages with convective storms and magnetic flares, the heart of the star is settling into a state of perfect geometric order. This crystal is the ultimate byproduct of the triple alpha process, a dense and lightless core where atoms are packed so tightly they form a rigid, metallic lattice. It is a sanctuary of structure amidst the dissolving gas, a solid foundation that will survive long after the rest of the star has vanished into the dark. This internal clarity is the star's final victory over entropy, a testament to the power of gravity to create order out of chaos. As the outer layers drift away, this crystalline core will become the star's permanent remains. It is a jewel forged in the heart of a sun, a dense and unchanging monument to the star's long-ago struggle for survival. The transition from a boiling fluid to a solid crystal marks the end of the star's active life, and the beginning of its eternal cooling retirement. The moment finally arrives when the star can no longer maintain its precarious, bloated identity. When the last of the outer envelope is blown away by the final pulses of the core, the hot, naked heart is finally exposed to the cold, pristine vacuum of space. This is the big reveal, the stripping away of the ruby-toned mask to show the brilliant white-hot reality that was hidden for millions of years. The sudden exposure to the void is a moment of intense physical contrast as the ultra-dense core meets the absolute zero of the interstellar medium. Without the protective blanket of its atmosphere, the core's intense ultraviolet radiation is allowed to stream uninhibited into the surrounding space. This light is a fierce, cleansing energy that instantly transforms the environment, signaling the star's transition into a new state of existence. The star is no longer a red giant, but a naked and vulnerable point of light that commands the attention of the entire local system. This exposure marks the birth of the white dwarf, a compact and powerful remnant that will shine for billions of years. The long red twilight has ended, and the short, brilliant dawn of the stellar remnant has begun. This structure of light and matter creates one of the most breathtaking sights in the entire universe. This exposed core, now a brilliant white dwarf, illuminates the expelled gas of its former self, creating a spectacular planetary nebula. The ultraviolet rays from the core strike the expanding shells of dust and gas, causing them to glow with iridescent shades of green, blue, and violet. The nebula is the star's final masterpiece, a glowing ghost of its former identity that can span light years across the dark. It is a visual symphony of the star's mass-loss history, revealing the intricate patterns and spirals sculpted by its final pulsations and companions. The white dwarf sits at the centre of this radiant cloud like a single brilliant diamond set in a veil of colourful smoke. This display is temporary, a fleeting moment of beauty that will eventually fade as the gas disperses and the core cools. Yet, while it lasts, the planetary nebula is a reminder of the incredible energy and complexity contained within a single star. It is the final, magnificent bow of a celestial actor, a farewell performance of light and colour that leaves a permanent mark on the memory of the galaxy. The red giant phase exists as a majestic temporary bridge spanning the vast distance between a youthful main sequence star and a silent stellar remnant. It is a period of intense transition where the star sheds its old identity and prepares for its final, crystalline form. This phase is the necessary connection between the burning of hydrogen and the eternal cooling of a white dwarf, a bridge built from expansion and alchemy. Without this bridge, the universe would have no way to distribute the heavy elements forged in the core to the rest of the galaxy. The red giant is the delivery vehicle for the building blocks of the future, a massive and glowing intermediary that ensures the continuity of cosmic evolution. It is a brief, high-energy era that defines the chemical fate of the solar system and everything within it. We live on the other side of that bridge, inhabiting worlds that were made possible by the bridge's collapse. This period of stellar life is the ultimate proof that endings are rarely final, but are instead the essential transitions required for new beginnings. The red giant is the path the universe takes to get from the simple to the complex, a journey of light that leads to us. Notice the stillness in the air around you, and realize that we look up at these swollen red stars not just as dying suns, but as the cosmic mothers of everything we have ever known. They are the providers of our atoms, the architects of our chemistry, and the original source of the warmth that allowed our world to bloom. To look at a red giant is to look back into our own ancestry, into the very forge where our material existence was first imagined. These stars are the guardians of the future, ensuring that their own decline is the catalyst for a much larger and more diverse story. Their slow, crimson light is a maternal glow, a sign of a star that is giving everything it has to ensure that the galaxy remains a place of possibility. We are the children of these dying suns, the living realization of their final alchemical dream. As the star finally settles into the icy silence of its white dwarf state, its work is complete. The matter it exhaled is now free to wander the void, waiting for the gravity of a new generation to pull it back together into a new sun and new planets. The story of the red giant ends, but the story it made possible is just beginning, a continuous cycle of light and life that knows no final conclusion. The final wonder of the red giant is that in its chaotic, dying expansion, it breathes the very atoms of life into the dark, ensuring that the end of one world is always the necessary architecture for the beginning of the next. Deep within the final breath of this crimson titan, we find the ultimate, quiet truth of our existence. The final wonder of the red giant is that in its chaotic, dying expansion, it breathes the very atoms of life into the dark, ensuring that the end of one world is always the necessary architecture for the beginning of the next. Every element within your physical form is an ancient gift from a star that chose to let go. This long journey through the starlight now draws to a close as the vast ruby-toned distances begin to fade into the gentle shadows of your own room. The echoes of the cosmic heartbeat grow faint, replaced by the soft, steady rhythm of your own breathing. Allow the weight of these wonders to settle over you like a warm, heavy blanket of peace. Notice the tips of your toes, letting them go completely limp and still against the cool, soft sheets. This relaxation travels slowly into the arches of your feet and up through your ankles, releasing any lingering tension from the day. Your calves and knees become heavy, sinking deeper into the soft support of the mattress below. Surprisingly, the body knows exactly how to surrender to the pull of gravity, allowing the thighs and hips to rest in total stillness. The lower back and the full length of the spine find their natural alignment, melting into the quiet comfort of the bed. Your abdomen rises and falls with an effortless, automatic grace that requires no thought or effort at all. This quiet room is filled with a peace that reflects the absolute stillness of the deep. The chest relaxes with every breath, and the shoulders drop away from the neck in a final release of weight. Your arms become heavy, still, and warm all the way down to the palms and the fingertips. If we were to feel the pillow, It supports the weight of the head with a perfect gentle firmness that feels like a cloud. Each breath in is a wave of cool, clean air that brings a deeper sense of rest to the lungs. Each breath out is a release, a letting go of the light and the noise of the many hours behind you. The shadows in the corner of the room are soft and familiar, wrapping around the bed in a protective embrace. These covers are heavy and warm, creating a small sanctuary of absolute safety and quiet. Softly, the rhythm of the room becomes the rhythm of sleep, a slow and steady tide that pulls the mind away from the shore. Your thoughts become hazy and indistinct, drifting like mist over a quiet lake in the middle of the night. You're completely safe, completely still, and completely ready to drift away into the dark. The silence is a thick, comforting presence that makes the world outside feel very far away. This sanctuary of blankets holds you in a firm, warm hug that tells the mind it is okay to stop. Every lingering tension has evaporated, leaving only the sensation of floating in a peaceful, quiet calm. The room is a sanctuary where time has slowed down to a beautiful rhythmic stop. And now, 101 wonders are resting with you. Sleep now. Good night.